And what you have to understand, Graham, is every single one of your graphs will have the same shape. What is that shape? A parabola. Okay? So if you are graphing it and you do not get a parabola, you have done something wrong. And you need to check your work or raise your hand and get help from a teacher. Okay? Also, this is the most important thing. If you have done it correctly, perhaps you will get those 3 dots right there, right? Those are, looks like half of a parabola.
Yeah.
Do not go like that and call it good. Okay? Is that a parabola?
No.
No. Finish the parabola. Okay? Make it look pretty. That doesn't look pretty at all. We can do better than that. Okay? Alright, so keep that in mind as we go. That your graph is going to be a parabola all the time. Alright? So let's start out with an easy one. Let's graph y equals negative 3x squared. Okay? Now, you can use your knowledge of parabolas.
Francis.
She said she wouldn't tell us.
I know. You can use your knowledge of parabolas that you learned yesterday to get an idea of what this graph is going to look like before you even make it. Tell me 2 things about this graph. 3 things. Okay, it's negative, therefore
It's going.
it will be going down. Okay. Okay, so that's one thing, is we're going to expect it to go down. Yes?
It has a y-axis of 0.
Okay, it's going to cross the y-axis at 0. And what's another thing that it's going to look like? It's going to be skinny, because 3, you don't look at the negative or positive, you just look at the number. It's going to be relatively skinny. Okay? So we can look for those 3 things. Okay? So here's how you do it. It's real simple. We're just going to take and make a little table. And we'll start with the easy numbers, negative 2, negative 1, 0, 1, 2. Okay, so work along with me. Oh, we're going to do 4 examples. So you can space out your graphs accordingly. If you want to do 2 on the front, 2 on the back, that's fine. Or if you want to divide your graph paper up into 4 sections and do 1 in each corner, that's fine too. Okay? All right, now I just need to take these numbers and plug them in for x and see what I get for y. So if I plug negative 2 in here for x, that's going to be negative 3 times negative 2 squared. Now I ask you, what do I do first?
Square.
Right, I square it first. And a negative number squared will always be a positive number. Anytime you square a number, whether it's positive or negative, you will always get a positive number. So negative 2 squared is 4, and then 4 times negative 3 is
12. Negative 12.
negative 12. Okay? Now I'm going to do the same thing, except I'm going to plug in negative 1. So the first thing I have to do is square negative 1, which gives me positive 1. And then 1 times negative 3 is negative 3. Okay? So move through that, please. Please don't do that. Okay, why would you do that? Why would you just flip garbage on my floor? Okay, please don't do that. Okay? Please don't do that. Okay? Okay, now if I plug 0 in for x, what's 0 squared? 0, and then 0 times negative 3 is 0, and that's what Nolan was talking about, that the graph is going to cross the y-axis at 0. Okay? Now I'm going to plug in 1, and something magical is going to happen. Okay? When I plug in 1, what do I get? Negative 3. Okay? Do you see the magic?
Yeah, now it's going to be...
Right, and now it's going to be negative 12. Yeah, and that's because it's a parabola, so it goes through these and then goes through them again on the other side. So if you plug in 2, you're also going to get negative 12. Yes? Okay, let me help you.
Okay, so we do 3x squared, right?
Correct.
And we have to give 2 y.
Because what's first thing I have to do is the exponent. So what's negative 2 times negative 2? Positive 4. And then what's positive 4 times negative 3? Negative 12. Okay? So square it first and then multiply by this number right here. All right? Okay, so now we just need to graph these. All right? So negative 2, negative 12, I'm going to have some problems with that because negative 12 is off of my graph. Okay? Well, you have the ability to control that by making yours bigger. I can't because it's at the end of the screen. So if you only made your graph go to negative 10, then draw that line a little bit further down. Okay? So I need to go over to negative 2, negative 12. So that's going to be a dot. We'll just play pretend. It's going to be way down there. Okay? Then I have to go negative 1, negative 3. So that's right here. 0, 0 is obviously right in the middle, and then it repeats itself on the other side. So 1, negative 3 is right there, and then 2, negative 12 will be way down there somewhere. All right? So then if I connect those dots in a smooth U shape, that is everything we hoped for and more.
No, it's not.
Which direction is it pointing? Down, because A was negative. Is it fat or skinny? Skinny because of the 3. And then like Nolan said, it crosses the y-axis right here at 0. Okay? All right? So your graph, your sketch, your drawing should match mine. Right, Tia? Yeah. Oh, she dies in the end anyway. It's not worth it.
You said that last time.
Always say that. Be lucky that you're not one of my kids. All right, let's do another one. I don't even know what book she's reading. What was it? Oh, yeah, she did. Okay, so let's go again. Okay. Yeah.
Is that a squared or?
Oh, yeah, that's a squared. They're always going to be squared because we're doing quadratics. But, yep, that's bad writing. Okay, so let's graph 1/3 x squared. Okay? So once again, think about what you're going to get before you start. Obviously, it's going to be a parabola because it's squared. Which way is it going to open, up or down? It's going to open up because it's positive. Okay? Will it be skinny or wide? It's going to be wide because I have a fraction in front. I have a small number in front, so that makes it wide. Okay? All right, so same thing as before. First thing I do is I take this number and I square it. Negative 2 squared is?
4.
4. And 4 times 1/3 is?
4.
4 over 3, 4/3. So we're going to have to estimate a little bit, but it's going to be all right. Okay? Good question, and yes, those are good ones to always pick. Okay? All right, now we take negative 1, Nate. Now we take negative 1 and square it, and what do you get? Take negative 1 and square it, and what do you get? 1. And then I have to multiply that by 1/3. 1 times 1/3 is? 1/3.
0, 1, 0, 4.
Okay, good. And then when I put in 0, 0 squared is 0. 0 times anything is still 0. Then when I put in 1, I'm going to get 1/3. So here's where the magic happens. And if I plug in 2, I'm going to get 4/3. Okay? So now I can graph this, and like I said, because I have fractions, I'm going to have to estimate a little bit, but that's okay. So when x is negative 2, y is 4/3. So that's just over 1, right? 4/3 is the same as 1 1/3. Okay? So I went a third of the way above the 1. Then when I go to negative 1, y is 1/3. So that goes right here. Okay, and then 0, 0.
That's a pretty hefty.
It's pretty wide, 1 1/3, and then 2 4/3. Okay? And if we wanted to know more about the shape, you could put in -3 or 3. Okay? But we can just take it from here and just improvise. It's going to look a little bit like this. Okay? So, yep, everything we expected. It's a parabola, it opens up, and it's wide. Graham, have you written any of this down?
That sounds
I don't know why. I don't understand why you do that. I don't know. I mean, what are you going to get on the test? I could guess. Kind of. Test, guess, test.
Yes.
Onomatopoeia. Something like that. Okay. All right. Are we good with that one?
Can you say the state fish of
What?
what?
All right. So, like I promised, we're going to do 4 all together. Let's make it a little bit trickier now.
Wait, say that again.
That again.
No.
Say the state fish.
Fish.
The state fish of Hawaii
State fish of Hawaii
is
is.
No, say the fish.
Why are you making me say these things? I don't get it. Humu humu nuku nuku wapua'a.
No, where do you learn that?
In Hawaii, of course. It's the Hawaiian state fish. It's also called the trigger fish. Humu humu nuku nuku wapua'a. There you go. All right.
what? There's a
Hey,
song about
hey,
it.
hey, hey. Stay with me. 2 more. Halfway there.
I thought this is on YouTube now.
Okay. So, exact same thing as before.
You only go up to,
As Alyssa pointed out, what are my x's that I'm going to use?
-2,
-2, -1, 0, 1, and 2, right? Okay, so now what's the first thing I'm going to do with each one of those numbers?
Plug it in.
I plug it in, and when I plug it in for x, the first thing I do is what? Square it. So -2 squared is
4.
4. 4 times 2 is
8.
8, and then I also have to add 3 and get 11. Okay? What? Oh, okay, that's fine. Same thing with -1. First thing I do when I plug it in is square it, which -1 squared is 1. And then I take that answer and multiply by 2, so 1 times 2 is 2, plus 3 makes 5. Okay? Now you have to be careful, this is a little tricky. If I plug 0 in there, what do I get?
You get 3.
You get 3, good. Okay? Because 0 squared is 0. 0 times 2 is 0. And then if you add 3 onto that, you get... Nope, 0 squared is 0. 0 times 0 is still 0.
Plus 3.
Yeah, you did say something.
Anything to the 0 power is 1. Okay, so if I went 3 to the 0 power, I would get 1. That's what you're thinking of. Okay, what am I going to get when I plug in 1?
1.
5. It starts to loop back around again. 1 squared is 1
11.
times 2 is 2 plus 3 is 5. And then, yeah, when I plug in 2, I get 11. Okay? So once again, I have issues here with my graph, but we'll work through it. I go -2, 11. -1, 5. 0, 3. 1, 5. And 2, 11. Okay? So that parabola is a little bit skinnier because of the 2. It's still opening up because it's positive. And why did it go up 3 places? Because of the plus 3 on the end. So basically what we did is we took the 2x squared parabola and moved it up 3 places.
Basically, it's like y.
It's a lot like y equals mx plus b, except the x is squared. Yeah. But no, you're right, because the plus b told us where it crosses the y-axis, and the same thing here, it crosses at 3. Okay? And you can kind of do the slope thing, Nate, with the 2. From here to here, you go up 2 over 1. But then after that, you don't go up 2 over 1. You go up, 6. So that changes. Humu humu nuku nuku apu aha.
It's like literally all my
I believe you, Paige.
I'm gonna guess you watched that. Like,
The very basically
Hey, Paige, I saw you at Taco Bell yesterday.
You did? When
Yeah.
Jocelyn and Tyson?
I was in the drive-thru. I was like, oh my god, there's Paige.
All right, last one. Once again, we can guess what's going to happen before it even does. Does the graph open up or down? Up. A, hold on, this is important. A is the number in front of the x squared. So if you looked at this and said because it's negative it's going to open down, then you need to make sure you understand why that's wrong. Okay? That A is the number in front of the x squared, not the number on the end. What's the number in front of the x squared? 1. Good. Good. It's 1x squared. And since that's positive, it's going to open up. Okay? And it's going to be about a regular width. And then what does the negative 3 do to it? It's going to make the whole thing move down 3. Okay? So if I plug negative 2 in there for x, negative 2 squared is 4. And 4 take away 3 is 1. So negative 2 will give me 1. Okay? If I plug negative 1 into there, negative 1 squared is 1. And 1 take away 3 is negative 2. If I plug in 0, 0 squared is still 0, and 0 minus 3 is negative 3. And then what happens?
2.
The magic happens, negative 2 and 1. So here's our graph.
Wait, how's that negative?
If I go 1 squared, I get 1, and 1 minus 3 is negative 2.
Yeah.
Okay, so it's going to do the same thing, loop around. So negative 2, 1. Negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, 1. So just everything we hoped for and more. It's a parabola. It's opening up. It's about normal width. And it's been moved down 3 spaces. Okay?
It's not the problem. Get some graphics. We can do this. We can finish it.
Or have a day.